Hi, welcome to this webinar from Cloud Academy. We will talk about Polyglot Persistence in Azure. I am Marco Parenzan, and I'm an Azure trainer at Cloud Academy, and I'm Italian. What we talk about? In this webinar, we will talk about going away from the relational legacy. That means how can you use some data storage different from relational databases. In general, there is a lot of fear moving away from a relational database. Fear that probably is about legacy knowledge. That means legacy databases, relational databases, are typically taught in school or in general for as much as 20 years from the 80s to the new century. We have always used relational databases. So thinking about using some different databases is quite difficult for a lot of people, for a lot of developers. Then there will be probably some DevOps cost issues. Let's say, okay, but how much does a different database costs for the solution? And then how much does it cost for DevOps? That means the IT pros that work on these systems, how much does they cost? For the developer in general, using some new technology is always an opportunity, is always a lot of fun. For the developer, it's time to rethink about your application. So trying to develop the application in some different ways. And if you think about cloud computing, moving legacy application to the cloud does not mean that the application works well in the cloud. And typically, if we have our application that is developed over our relational database, in general, it is not a great performance. It does not have the same performance that it has on premise. So, moving away from legacy relational databases means approaching some NoSQL persistence, where NoSQL means not using the typical relational databases. So using different persistence services inside an application. And then speaking about polyglot persistence means using different persistence services in the same application and at the same time. That means inside an application we use not one but two or more persistence services at the same time. And if we talk about what we have said before, not only SQL databases. If you want to learn more about polyglot persistence, about the theory, there is a well-known developer that is Martin Fowler that has written about polyglot persistence in 1211 on his blog. And for example, I have catch an image from his article where he writes about a single application has many different data, and each data is well suited for a specific service, for a specific database or persistence storage. So we want in this webinar show how to do the same thing in Azure. Yes, cloud is an opportunity because it has so many services available to the developer, to the IT pro. And then the DevOps has lowered barriers to adopt that services and cost, because in general cloud introduces a pay-per-use cost, so you have no capital expenses to try a software, but you can just use a service. And in general, because cloud offers many ways to use services, you can prefer platform as a service over infrastructure as a service to use these new storage opportunities. Azure is a great opportunity to try Polyglot Persistence because, again, he has so many services and it's widely available worldwide with up to 38 regions. It's interesting because from Microsoft documentation we can find this nice poster that you can find in the URL that I have written in the slide. And here you can find a lot of patterns. That means how do you write code in some situation around the code you are writing. And then you see that with the red boxes that I have put on the poster, you see that all these patterns selected are persistence pattern. In fact, these patterns refers to some kind of storage data that is used inside the application. So, thinking about patterns, probably there are many different ways to implement that patterns. Azure has a lot of services available to the developer, and that services are just implementation of that pattern. So you can use one of many services to have already that patterns already implemented. You have just to plug inside your application and use. These services are just a few of the services that are available. More are available on Azure. Then there are also many open source softwares available on Azure that can also implement the same patterns we are looking for. In fact, if we look at databases and middleware, you find that there are a lot of open source databases that we can use in our cloud application and in Azure. In general, which kind of persistent needs do we have in our application? In general, if we don't think about relational databases where we speak about tables and relation, we speak about document, for example, better expressed as JSON document. Key value stores where you persist blob of data referred to a key, or caching where key value store is persisted in memory for fast access. Then we can have more vertical persistence services about search for to optimize search of data, or queue where the need is to handle data in a strict sequence how they entered inside the queue. And there are many more that we will not cover in this webinar. So let's look at some code so you can understand better what does mean working with Polyglot Persistence. And think about a company that has a traditional ERP developed with a relational databases but wants to create a web ordering system, so an application that is surely deployed in the cloud and that can now, about what we have said, take the opportunities of many persistent services that Azure has gives to the developer. So the steps that we need to do are, in general, we can say 3 major steps. We have to export documents and images from the database, from the relational database to the cloud. Then we will have some different operations that we do in our application that will use different storages, and then when we receive the order, we send back to the original relational database. So let's go to our long demo. This is a web application. At the moment, it is running on premise in this at the moment on my machine. This is an Adventureworks web storage. You can find this data on cloud and or on SQL Server, because Adventureworks is a famous ERP databases for SQL Server. Obviously, this database is just a sample, and you can use any database you need to do the same thing. What does this application do? Is we can say just a product catalog, because you can authenticate. You look at the product catalog, you see some details, and you can add to cart and then send the order. That's our demo. So, what does means working with Polyglot Persistence and working with something that is not only a relational database? Okay, so let's go to our SQL database. We are under SQL Server at the moment. To be real, we are under Azure SQL Database, that is the SQL Server like in a platform as a service mode in Azure, where I have deployed a database that I have called Polyglot Persistence. I will use this name everywhere for the services, and you see that you find all the tables that are typically from the table inside the Adventureworks sample, where you have, let's look inside the data, when you have a product table, you have some customer table. Okay, you see that you have product table, you have related tables like category. In fact, you have a product category ID that is an external key, and you have a product category. It's the same for model, and then you also have customers, for example. Or you have sales order header and sales order detail, that is the master detail for order processing. Okay, so what we want to do first? First, we want to create a database for the web application. So we want to move away from our relational database, and we want to store our data on something different. The best choice at the moment for a web catalog in the cloud, it's about using Azure Document DB. This is my Azure account where I have all my services that I have created for my application. You see that here we have a lot of services. In C, for example, we have NoSQL, that is document database. DocumentDB is the NoSQL proposal for document-based, JSON-based database in Azure. Document database means that we have no relations, we have unstructured data, that means no schema that can check inside my document, but we have the meaning of collection. In fact, you see that inside this database, this account, Polyglot Persistence, we have document collection. Here we have some metrics that works with our collection. Okay, we see that we have a Document Explorer that look inside Adventureworks database, inside the document collection. Here you have the IDs of our document, or our documents. If you look at the documents, I click on that, and you see that here what I have a JSON document that uses quite the same properties that we have found in our relational database. But you see, for example, that we have a product category and product model that has that is a complex object. It is not just strings, numbers, dates, but are objects themselves which contains our properties. In general, a JSON document is not a flat property value container, but it's a quite rich container of properties that can be scalar properties or object itself. This object can be more than 1 or 2 levels deep. DocumentDB is a document container, but it is also a database that can be queried with some language. One of the nicest things about DocumentDB is that it has a query language that is built with SQL syntax. In fact, you see that you can write a select star from C, where C is just a placeholder, and you see that here you have a result of our document. But you can also do a projection. For example, where we have c.name, c.product number, c.color, and also c.product category dot name as category. If we run the query, you see that we can do a projection where you have just the 4 property you need. And then you can also do where c.color equal red. You see that we have filtered our document with a red value. Why do you're thinking, why do I need moving this kind of my application to a DocumentDB, to a NoSQL database? There are many opportunities and why we can move. For example, here you see request charge. With DocumentDB, you always know how much does a query cost, because collections, where are the containers of our documents, are sized to be able to execute an amount per, here we say RU, that means resource units. You buy a collection that is able, for example, to execute 2,500 resource units per second. This query was able to cost 19 resource units per second. So, for example, you can this kind of query you can execute about 100 or 150 queries at the same time of this kind of query that returns this kind of document with this size, with this number, that are 38 documents. So DocumentDB is moving to a predictable database that can allow you to calculate predictable costs. Then another thing that tells us use DocumentDB is about the geographical distribution. You see here you have a regional distribution. You see that we are on the East US region. Here we have the database, but here I can, for example, click on one of these hexagon and I have automatical replication of the data, and so I can, for example, access to copies of data on our region automatically. Or, for example, you can have a default consistency. When you are working, we are used to work with a relational database, you typically work with strong consistency, or what is equivalent to strong consistency. That means that the database does not give you back the control to the data until all tiers inside the database are updated with the same data. With NoSQL, we are used to work with consistency. That means, can the database be less consistent than strong? Yes, because we are normally in DocumentDB we are under session consistency, or you can move on eventual consistency. That is the typical example where we speak about NoSQL databases. Why do we move, for example, in eventual consistency? We move to eventual consistency because we want to write. We want to write a lot of documents, but we don't need to read that documents. So you want to allocate all the resources of that data, of that database, to the right part. So you can acquire a lot of documents in the unit of time. This is a particular opportunity that you have with NoSQL distributed database. So what can we do? If we go to the code, yes, the documents are already inside DocumentDB, but if we go in my project, you see that we have some documents. For example, here we have some projects, we are data model, that is the classes that represent, that maps directly with the records in the SQL Server database. We have product model, product category, that are written as a relational model. But here we have a web model that is, you see that we have the product model DTO, that is name, catalog, ID, or we have, for example, product detail DTO, and where you see we have ID, name, product number, the same properties, but here you see that you have product category DTO, where product category DTO is ID with name. So you see that you can have complex classes that does not contain only scalar property, but also object properties. So migration is having an application, for example, that is SQL to Azure Storage. But what does he do? He connects, Azure Storage with DocumentDB. That's it. Here you have connecting to a DocumentDB. Here is the how do you connect to DocumentDB with a .NET SDK. The .NET SDK is just one of the SDK available to connect DocumentDB, that has a REST API, so you can query and you can interact with the database with many other languages that support JSON communication. Here you have database indexing, and here you are. Here is the loop where you connect to the relational database, you create the document, the object, but it is transformed to a DTO, that is mapping the relational model to the non-relational model, and then create the document in DocumentDB. This can be a short or long process. It doesn't matter for us. In fact, I have already loaded the documents inside the DocumentDB database. And in fact, as I have already showed you, inside products, here you have our query, our pages that is filled from the DocumentDB database. Here you see that we have 10 rows. We have a continue button that means, okay, a continue loading of all the contents. Let's look in the code. If we go in the web front-end project, we see that we have controllers, that is products controller. In the products controller, we have a lot of code. We go to index, that is just the web page, but here we have items, that is a call, an AJAX call, that means DocumentDB products, and we can look at this. You see DocumentDB is a query, a client create document query about an object product detail DTO that queries about our document. And here you build up the JSON object that will be given to the client page. So what happens if we click on details? Okay, here we have the document. Here we have an image where also no image available is an image. Okay, how do we build this page? This page is written in about the same way, but there are some specific features. For example, here you see that we have details, where to receive the ID of a document. Here you see that we have DocumentDB products, where ID And if it is found, okay, let's skip this row by the moment, and you see that we have view about the result of a query, and then the properties are written inside the page. So you can query the same database as for index, so you can project the properties as you do in relational database, or you just read the entire document and put on the page. This is one of the advantages in general of a DocumentDB database or a DocumentDB NoSQL database, that with complex object you have just one query and no joins to do to retrieve the entire data. In fact, we normally call this data DTOs, data transfer object. Let's see one thing that is about the image. You see that in the model there is a thumbnail photo name. That means give me the file name. And you see that at the same way, here you have model.thumbnail photo file name. That is the file name of the image. But where is the image for this product? If we go on the original SQL database, you see that the thumbnail photo is inside the product table, stored as a var binary max. In general, we can say that the thumbnail photo, that the var binary max is a blob for the database, because SQL does not understand what kind of data are inside that big binary data. And there can be also some performance penalties, because storing a big table with large blobs can be difficult for the performance of a SQL database. So what we can do for our web application, because we are speaking about blob, in Azure there is a great service for storing blob storage, that is using Azure Storage, using a storage account. Here you see that we are using a storage account that is one of the founding services for Azure, because it can handle blob content, file content, table content, and queue content. Blob content is a set of containers. In fact, you see that we have web front-end images. Inside, you see that here we have our files. In general, in Platform as a Service, prefer for files for blob storage not to use a file system, not to use relational database, but use blob containers. At this time, with Azure, you use storage. You have also nice tools, for example, this Azure Storage Explorer, that allows you to navigate inside your storage. In fact, you see we have front-end web images, and here you can just download, upload, as you would work in any database, in any file system. In my application, I have written this application, that is SQL to Azure Storage. But what does it do? It connects to the products list in the database, then opens a blob client inside a storage account that uploads, you see here, upload from byte array, that loads from my machine to the cloud. The nice thing is that when a blob is loaded inside a storage container, it has, if the container is configured properly, obtains a public URL. In fact, you can click on this URL, go on the web, and you see that I download the image. So, if you have to store blob storage, relational database is not the most convenient and less expensive storage you can use. Storage service is the best storage you can use to store blob information. Okay, what's happened? What happened that if you are looking inside a catalog, probably you go on the same page more and more times. We can also speak about queries, but we leave queries we have already done. But speak about queries. With details, the product does not change for, I think, some quite time. It can be hours, days, or weeks. So if we obtain a document by ID, probably if we go again on the same document, the document is the same. So we can save resources accessing to the database, and we can improve our performance in retrieving the data if we use some caching level that allow us to say, okay, I have a detail with AID. Let's see if we can find this ID in some caching. And here we use Redis as a caching service. Okay, if ID is not present in Redis, okay, query over original database, and then convert into JSON formats, for example, and store it on Redis. On the next time, when I go again to the same detail ID, I look if the key is present, okay, is present, and then you see that Redis has the document, and then I can get the key and then send back the object. In general, using a caching tier when in front of our query system to check if the document we are retrieving is already in the cache, on the long and on the big, as big becomes our project, our document, our performance improve and the cost become less. So if we just go to our Azure account, you see that I have created a Redis cache. Okay, so let's get back to the application, and here what we see that we have our product, and we have a possibility to add to the basket. I can check the quantity, okay, add to the cart. You see, I have added something to my cart. I go again to products, and then I can buy something else. Add to cart. Where do we store the cart? What is necessary for the cart? For the cart is necessary to have the key for the shopping cart and the key for the single entry. because when we retrieve a shopping cart, we need the entire shopping cart, not something part of it. Or so the page is get my entire shopping cart, or go to a part of a shopping cart. That means, okay, retrieve some information. For example, I want to improve my quantity from 1 to 2. I can do edit. I can add and go back to 2. No, I have to make a mistake. Not 2, but 3. Again, edit. You see that there are 2 and can go on 3. You know, for the shopping cart, we have a table because we have some properties, but we have some difficult query system because we need to access by key at most, by the shopping cart key and the product key. How do we do that? Azure Storage contains tables that are not relational table, as Azure Storage is not a relational database, but is a structured, a quite more structured key value store that contains properties and rows. And you see that each row has 2 main keys, partition key and row key. In this sample, partition key is our basket key, is our session that we are buying, and the row key is a session key. You see that we have all the properties that we can also edit in this in this moment. Azure Storage contains tables. So if we go on products controller, we see that shopping cart items, and you see that we have shopping cart content that is here, and you see that we have table client, that is another object to access tables in Azure Storage. We can do a query, that means give me object by partition key, and then fill up items. When we need to edit, when we need to add, I go up, you see add to cart is table client, retrieve if exists, or if not exists, create the object, and then insert or replace operation on the shopping cart. So if you need table structured information, but you need just to access by key that becomes your partition key or row ID, then table storage can be your solution. For example, for carts in a basket, is a good solution. And here again, you see that you have tables inside. Okay. What about search? Search, because you can have a lot of items in your catalog. Sorry for the latency, but if you want to search and you have a search applet where you can type something about the product or some properties, and you obtain the rows that satisfy your query. Now that we are waiting, probably there is some connection issue. If we go on Azure account, you see that we have Azure Search Service. Azure Search Service is about indexes. Azure Search Service is another kind of database, typically database that works with columnar indexes, that can support you on text searches, in fact, you see here you have indexed properties on which you can do searching, filter, faceting, sort, and retrieve. And then you can also do some suggestion. We will show after. If you use, for example, you have two important functionality. Import data is about connecting to your data sources. For example, what I have done is connecting to the document DB, so it can import your data. And then you have Search Explorer, where you can try experiencing here. For example, if I look for red, if I look for red, you see that you obtain a result of a query, and you see that you find red, for example, in color. But you see that I have done just a pure query string. If I look at road, you see that he is looking about the road inside the title. Or if we look at something else, we can find 430. You see that you find here, you find the value. Okay, and you see that you obtain a search score. That means about your query, how does the document matches about your query. What is interesting as a developer is that when you perform a query, okay, here you have two functionalities. That means I can type, sorry for latency, if you type red, for example, you obtain the suggestion. And we can, now that it is querying, the latency is probably my connection, because the application is on-premise connecting to the original databases. Sorry. And here you have, I go to suggest. You see, I search for red, and search support you on suggest, because you look for that text. He looks inside the index, and then he give me back the result. Or if I look for some text without suggestion, he can get me the text, the result, just with a text query. We don't need to create particular query like we will always do on relational database to say, okay, save it on the looking description in category. We have to compose a quite complex SQL to try to find a full text search. Here we have a service, this is Azure Service, that can do the work for you. Okay, here you see that you have the suggestion, and you can do your query. That's it. Okay, so now that our shopping cart is composed, I move the screen so I can show you. What about I want to show you something complex. That means we can show here. Sorry, I show you here. What I show you? What about submitting the shopping cart? We can just do a click, but what do we want from a shopping cart? We want to process all the orders on order. Let's see, the first one is entered, is submitted. This is the one that I process. And again. So what does this mean? This means that the shopping cart, the order, should be submitted on a queue. So if I click on submit order, you will look on the left that something will happen if demo is not will work. Okay, I have not seen. Okay, you see that I have a function started. Okay, you see that I have order ID. This is the order that was submitted and it was processed. What happened? I have pushed the submit button. I have sent the object, the cart, inside a queue. You see that here you have a queue. Then what happened? The queue triggers a code here, this function, and take the queue, the message, inside to execute a query. And you see that execute handle order, that is a store procedure, on a SQL connection. That means I have received the order and I have inserted inside SQL. In fact, if I go to look at the SQL, okay, I connect. Change the database. And go. Here you see that the order was submitted to back to the ERP database in the sales order header, sales order detail tables. Again, how? From the basket, click on submit order. If we look at submit order, you see that we have get queue reference, where queue is inside again the same storage account. Build up a message that is order ID, customer ID, username, and items, serialized, and then sent to the queue. An external services, that is function, is triggered by the presence of an item in the queue and insert on the store on the SQL. The store procedure, what does he do? Let's check. The store procedure, and you see that the store procedure has an order message, and here, using one of the latest features of SQL, can allow us to parse the JSON value and insert back to our ERP system. For example, open JSON, queries up our rows inside the order, and then insert the sales order details table. Okay. So our journey is completed. So to give a conclusion, and I invite you, now that I say the conclusion, to write some question if you have some question of what we have seen in this presentation. So what I want to say is about At first, platform as a service is an opportunity. Why is an opportunity? It's an opportunity because you can approach a greater set of services without the needs of issues about deployment and configuration, because services are ready to use, just to set some parameters that allow you to use that, and typically you have just a connection string to connect to the service. Multiple persistent services is an opportunity. Why? Because you have, I hope you have understood that every single feature of our application can have its specific storage. Yes, I know that the skill needs to be updated, but this is a requirement if we want to use cloud to have our major update, that is scaling, massive scaling, that clouds allow us in an easy way. So, about a question, what about security of data in DocumentDB? Okay. So let's go to the Azure portal. Oh, we go on NoSQL here. First, DocumentDB is a platform as a service, so you don't have an on-premise, implementation of DocumentDB. That means that you cannot install DocumentDB on a virtual machine or at home. This means that as standard, the service will be accessed from the back end of the services in the cloud. In general, there is an access key. So to connect to the database, you have a URI, a primary key that allow you to connect. In general, you have a primary connection string, that means the entire connection string that you configure and you access. Or you have read-only keys, that means, okay, you can look inside the document, but you cannot read the document. So the approach is the shared access secret, like for Azure Storage. With this connection string, you can connect. If you cannot connect, you cannot access. You have no, if the question is, there is a user management. No, there is no a user management. And there is a feature that is in preview, so it is not activated on my account, that is DocumentDB can filter IP traffic. Yes, I don't have it here because it is on preview. You can limit, at the moment the service is open to every IP, but you can add a filter to allow accessing only just an IP. But this is a feature that is just presented last month, so it is in preview and will become generally available in some weeks or months. I hope this enough as an answer. I invite you to make some other question, or then I can tell you that the presentation and the entire code will be uploaded on my account. So then we will publish all the presentation, the webinar, so you can look again the webinar anytime you want, and you can contact me via email or by the forum as you want, and you can ask me everything you want about Polyglot Persistence. There are many other questions. So again, I invite you to to use our community inside our website to post some question, and it will be a pleasure to answer you to any question you need on Polyglot Persistence, on DocumentDB, on the service you have written, on the code I will share with you, or anything you need with Azure or cloud computing. So, if there are no some other questions, I say thank you for attending this webinar. You will find here, you see our URLs, you see our website, you will find our webinars, and if you want to train with us on cloud, on Azure or cloud in general, you find on our websites all the information you need. Thank you.